I will go through 6 problems involving some basic concepts in inequalities. The first one we'll touch on here is interval notation. These two numbers are written in interval notation. Notice the square bracket and the parenthesis. There's a few possibilities here, okay? For interval notation, you could have square brackets on each side. You could have parenthesis on each side. You could have a combination, square bracket and parenthesis, as we do here. Or they could have it the other way, parenthesis and square bracket. So these are 4 possibilities. For each of these, they would have some numbers inside. I'm not going to graph these, but maybe to try to make the point. I don't know if you'll be able to see this, but this could be, say, 5, comma, 12. This could be negative infinity, comma, 3. This could be negative 8, comma, infinity. And we'll say negative 7, comma, negative 2. So they'll always have 2 numbers in there. But the key thing, interval notation, means you're going to use these symbols and you'll have 2 numbers inside. Alright, for the first one they want us to graph this set, so we'll need our number line. And let's say 6 is in there, so I'll have 6, 5, 4, and then 7, 8. I think that's good enough. Okay, so to graph this, the convenient thing, if it's already in interval notation, you use the same symbol as interval notation for graphing. Okay? So 6, basically the values they're describing include 6 and they go all the way out to infinity, but you can never touch infinity, so it just goes in that direction. That's the positive direction. Okay? So we start at 6 and then we go towards infinity, and so we just fill this in and we would just put an arrow in that direction. It indicates it keeps going forever. Then write the inequality statement in X. Okay? If you already have this, this might be a good way, a good step here, because it might be a little easier to understand what values X can be. X could be 8, X could be 500, X could be 7, it could be 6.5, all the way down even 6. But X could not be, say, 5 or 4, it can't be 5.5, can't be anything on the other side of this bracket. So we would say X is greater than or equal to 6. So the inequality statement in X is written right there. And you basically just have to learn to read what this means, what this means, and what this means. If you try to mechanically go, well, an X is sitting here or it's sitting there, it's going to cause you more problems. Just understand the logic of what's written and you will be much better off. It may take some getting used to. Incidentally, sometimes in other courses, instead of using a square bracket, they'll use either an open circle or a closed circle. In this course, we're just going to use these square brackets or parentheses. Okay? Let's take a look at number 2. And they're going to have us do this again. So again, this is already in interval notation. Okay, so we need to graph that. Well, we'll need our number line. Slide this over a little. And we're going to have values all the way out to negative infinity and coming up towards a negative 9, but nothing greater than a negative 9. So we'll say negative 7, and so forth. So the negative 9, we'll use our curved, our parenthesis, and then to fill in the values, x could be a negative 10, it could be a negative 11, it can be negative 9.5, it can come all the way towards negative 9. It's never actually allowed to be a negative 9 though, and that's what these curved parentheses indicate. So you simply shade in to the left and make sure you have your arrow pointing in that direction. We'll take, oh wait, then they say to write the inequality statement in X describing this inequality. So X is anything where we have it shaded in blue. X is less than negative 9. Notice in this case we did not say less than or equal. It is less than negative 9. It can never be actually negative 9. So that's our inequality statement. Okay, for this one they want us, they don't give it to us in interval notation. They give us the inequality. Then we are to graph this on a number line, and then they'll have us write the interval notation. So to graph that inequality, x is greater than or equal to 9. So here's our 9. X is greater than or equal to, that means it can actually be equal to 9. That means we can use our square bracket and we fill in to the right. Make sure your arrow's there. Okay, now we're to write this in interval notation. X can actually touch 9, that means we use the square bracket. Comma, and it goes out to infinity. Again, it can never touch infinity, but because that's not a certain number, it just says it keeps going forever. And since you can't actually touch that value, you always have to use a parenthesis for that. And again, I really need to emphasize, this is interval notation. Okay, now we're going to have to solve the inequality. So we'll have to get x by itself. Then we will graph it, and then we will write it in interval notation. Solving inequalities is much the same as solving algebraic equations. You can treat the inequality sign as an equal sign. The only case where you have to treat it differently is if you multiply or divide by a negative number. and we will have an example later on in this video. I want to get rid of the 4, so I divide by 4, divide by 4. Here those cancel. So we end up with x is less than -3. We have to graph the solution set. Maybe I'll work vertically here. X is less than -3. So here's our -3, -4. It can never actually touch -3, so I have to use the parenthesis. It actually goes right over that. And then it can be any value less than -3, so it goes out to infinity in that direction, to the left. And now for the interval notation. This indicates it's never equal to -3, but it gets very close. And it goes out to -infinity. And again, you can never touch the infinity. That's why you always have to use parentheses. So this is our interval notation. Again, we're to solve the inequality, then graph the solution set, and then write it in interval notation. First, to solve it, I want to get rid of the 5. I'll add 5 to each side. Doesn't look like much of a plus sign, but it is. Bring down your x, greater than or equal to. We're left with -2. Now we need to graph it. So here's our -2, -3, x is greater than or equal to -2. That means it can touch it, and it's going to continue in this direction off to the right. If it can touch it, I use the square bracket. Shade it to the right because it's greater than or equal to. And now we're to write this in interval notation. So it goes from -2 all the way out to positive infinity. That's our interval notation. Okay, for this one, we're to solve the inequality. Again, graph it and then write it in interval notation. I want to get rid of that -7, so I will divide by -7, divide by -7. So that cleans up and we get x. Uh, 21 divided by -7 is -3. But we just divided by a negative number. That means we have to reverse this inequality sign. Okay? I said that you can treat the inequality just like an equal sign, except when you multiply or divide, which we're doing here, by a negative number. So instead of it facing that direction, we have to reverse the direction that the inequality faces. Now we're to graph the solution set. And -3 sits in the middle. At least that makes it easy to make a quick graph. It doesn't have to be in the middle, by the way. And it's time for, oh, we're still graphing it. So let's see, we will, x is greater than or equal to -3, so it's going to be going off to the right. That means I'll put my bracket right here, opening in the direction, in the positive direction. I'll shade this in and then fill in the arrow. And our last step, write it in interval notation. We've got all values from -3 to infinity. Out to positive infinity. And you always use the parenthesis on that side. So again, this is the interval notation.